Hello students, so this video will be the last example we'll do from the homework in section 8.2, and we're going to look at question 5. The problem says a group of third grade students is taught using a new curriculum. A control group of third grade students is taught using the old curriculum. The reading test scores for the two groups are shown in the back-to-back stem and leaf plot. So at a significance level of 0.01, okay, is there enough evidence to support the claim that the new method of teaching reading produces higher reading test scores than the old method does? Okay, and then the problem says assume the population variances are equal, and they complete parts A through E below, and then it says also assume that the samples are random and independent, and then the populations are normally distributed. Okay, so the first part of the question asks us to identify the claim and then state the null and alternative hypotheses. Okay, so which is the correct claim? Okay, so be sure to reread the problem if necessary to identify the claim. Okay, so at a level of significance equal to 0.01, okay, is there enough evidence to support the claim that the new method of teaching produces higher reading test scores than the old method? Okay, so carefully read the answer choices below and then select the one that most closely matches the claim that's given in the problem. Okay, so answer choice A makes the most sense here. Okay, so now it's going to ask us to identify the null and alternative hypotheses. Okay, and then it tells you that U1, okay, represents the mean of the test scores of those taught with the old curriculum. Okay, and the mu2 represents the mean from the new curriculum. So, and then it tells us to identify the claim, right? So, which one of these hypotheses, the null hypothesis or the alternative, is the claim in the problem? Okay. No, so first of all, according to the claim, right, the new method of teaching reading is going to produce higher test scores. Okay, so in other words, the mean of the second group of students who are being taught the new curriculum should be higher than the mean for the first group of students who are using the old curriculum. Okay, so if that's the case, right, if this is a higher number than this, and keep in mind we don't know what these numbers are. Okay, we don't have the entire population of third graders using the old curriculum and the new curriculum, right? So if the second mean is higher, okay, it means the difference between the means is negative, right? So again, if you take a smaller number and then subtract from it a larger number, right, the result is going to be negative, like 3 minus 5 is negative 2, or 7 minus 10 is negative 3. Okay, so again, by definition, if the second mean is higher, it means the first mean is lower. Okay, so a lower mean minus a higher mean is negative. Okay, so for the alternative hypothesis, right, we have that the difference between the two means is less than 0. Okay. So then what do we put in the null hypothesis, right? So it's still going to be compared to 0, right? We're going to compare this difference to 0. Okay, but what symbol do we use here? Okay, it's going to be the opposite of the greater, or I'm sorry, opposite of the less than symbol. Okay, so the opposite of less than, so not less than would be greater than or equal to. Okay, so in other words, the null hypothesis is opposite of what the alternative hypothesis is. So if the difference between the two means is negative or less than 0, right? And then in the null hypothesis, we assume that they're greater than or equal to 0. Okay, so that's how we're going to set it up. And then of course the claim would be the alternative hypothesis, right? Where we assume that the mean reading test scores in the first group is lower than the mean reading test scores in the second group. We're using the new method. Okay, so the claim is the alternative hypothesis. Okay, and because the less than symbol is being used, okay, this is going to be what's called a left tail test. okay, which means that the rejection region of the test will be in the left tail of the probability distribution. Okay, but let's go ahead and answer the questions here. Okay, so the null hypothesis is that mu1 is less than or equal to mu2. Okay, so if the difference is greater than or equal to, not less than, but greater than or equal to. So if the difference between the two means is greater than or equal to 0, that means the first mean must be greater than or equal to the second mean. Okay, likewise, if the difference between the two means and the alternative is less than 0, right, it means that mu1 is less than mu2. Okay, and then again, which one of these hypotheses, the way that we've set this up, right, which one is the claim in the problem, right? Which one matches the claim? Okay, and it's the alternative hypothesis, right? Because we assume, once again, that the reading test scores in the first group using the old method is less than the reading test scores than the second group. Okay, which explains why their difference is negative. Okay, so just like with the other examples we've done in the previous videos in section 8.2, we're going to find the critical values, okay, that are based on this level of significance. Okay, but now this is slightly different because in this problem we have a left tail test. Okay, in the two previous examples we did, those were two tail tests. Okay, so how we find that critical value is going to be slightly different. Okay, so once again, how do we know that this is a left tail test, right? You look at the symbol being used in the alternative hypothesis. Okay, notice how the less than symbol points toward the left, right? The pointy end is toward the left there. Okay, that's how we know it's left-tailed. Okay, if this were somehow greater than, right, it would be the other way around. It would be a right-tailed test, right? If this were a greater than symbol, right, the pointy part is to the right. Okay, once again, if this were not equal to, it's a two-tailed test. Okay, so so before we get the critical value, okay, of the test, okay, remember that the problem said that we're assuming that the population variances are equal. Okay, so there might be reasons why we do that. Okay, but we won't talk about that. Okay, because in some problems it says that the population variances are not known, right? Which means we don't know whether they're equal or not equal. Okay, in this case, we're saying that they are equal. Okay, so that's going to affect how we find the degrees of freedom for this test. Okay, so once again, so when the problem says that the population variances are equal, okay, there's a specific way in which we get the degrees of freedom. So remember, n1 is the size of the first sample, and then n2 is the size of the second sample. So according to the book here, on page 428, okay, the degrees of freedom for this hypothesis test, when we assume the population variances are equal, right, is n1 plus n2 minus 2. Okay, we did this in the previous example. Okay, so if we go back and look at the problem here, all right, it doesn't really tell us what the sample sizes were. Right, it shows you the data in a back-to-back stem and leaf plot. Okay, so what you do here is you look at the stem and leaf plot. So these are the stems of the data values. Okay, and then the numbers to the left of the two vertical lines are the leaves. So you count the number of leaves. Okay, I'm not going to do that here, but if you count the number of numbers here on this side, okay, that's the size that's the size of the first sample. Okay, likewise, if you count the number of numbers on the right-hand side, okay, not including the stems in the middle, but if you count the numbers on the right-hand side, okay, so those are the students in the sample who were exposed to the new curriculum. Okay, so if you count the number of numbers carefully, okay, we'll get the sample size for the second sample. Okay, so I did this off camera, so I counted the number of numbers here. Okay, the number of leaves on the left, okay, and the number of leaves on the right. Okay, and I found that 19 randomly selected third graders were exposed to the old curriculum. So N1 is equal to 19. And likewise, for the other group of students who were exposed to the new curriculum, right, were 25 students. So N2 is equal to 25. Okay, so again, according to the formula in the book, okay, the degrees of freedom when the population variances are equal is n1 plus n2 minus 2. So you can simply plug those into a calculator. So 19 plus 25 minus 2, okay, is equal to 42. So we're dealing with 42 degrees of freedom in the problem. Okay, 42. Okay, we need that to find the critical value or critical values for the problem. okay, which we'll get in just a moment here. So we're going to go to StatCrunch. Okay, go to the Stat menu, select Calculators, and then select the T calculator, the T distribution calculator. All right, and remember that this particular hypothesis test is a left-tailed test. Okay, so the rejection region of this test will be in the left tail of the T probability distribution. Okay, so when we use the T distribution calculator to find that critical value, okay, in this case for the left-tailed test, okay, and this is true for the right-tailed test, you're going to select the standard option, okay, not the between option. Okay, we do that for a two-tailed test. So select the standard option, enter the degrees of freedom in this box here on top, which is 42. Okay, so for the left-tailed test, you would select the less than or equal to symbol. For the right-tailed test, you would select the other symbol. Okay, but in this case, we're going to type in the level of significance, so 0.01. Okay. Right, if this was somehow a right-tailed test, right, you would enter that same level of significance. Okay. All right, and it should give you the okay. Let's do that over again. So we're going to 0.01 in that box, and then the critical value will appear in this box. Okay, remember this is a left-tailed test, so you're selecting the less than or equal to symbol. Okay. So here the critical value is negative. So negative 2.418. Okay, they're usually rounded to 3 decimal places. So negative 2.418 is our critical value. Okay, so remember when you use the T distribution, right, for left-tailed tests, right, you should be getting a negative critical value. Okay, if this were a right-tailed test, your critical value will be positive. All right. Okay, so let's enter that in as our critical value, rounded to 3 decimal places. So negative 2.418. Okay, and let's select the rejection regions. Okay, so remember the critical value is negative, and this is a left-tailed test. Okay, so you're going to look at these answer choices carefully, and they may not make a whole lot of sense. Okay, but you may remember from previous examples that we would never select this option, right, where the t values between the two critical values. Okay, that's not going to be the case for any hypothesis test. Okay, we would select this option, option B, if we had a right-tailed test. Okay, option C if we had our two-tailed test. Okay, so the only other option that makes sense for the left-tailed test is this one here, so option D. Okay, so the rejection region is less than our given critical value. Okay. Okay, now it's asking us to find the standardized test statistic. Okay, so what we need to do to calculate the test statistic is we either need a summary of the data, okay, or the actual data values. Okay, the problem does not provide us a summary of our data, right? It doesn't give us the sample size, the sample mean, or the sample standard deviation of the two data sets. Okay, but what it does give us is a back-to-back stem and leaf plot, okay, of our two data sets. Okay, the students using the old curriculum on the left, and then the students using the new curriculum on the right. Okay, so it tells you here how to read the stem and leaf plot. Okay, so for example, if the stem is 7 and then one of the leaves to the left is a 4, okay, that means that test score for that student is 74. Okay, that belongs to the old group of students. Okay, likewise, the 0 to the right here means that in the new group of students, you had a student with a test score of 70. Okay, so I've already entered the data into StatCrunch. Okay, so for the stem of 3, for the students using the old curriculum, right, there's one student who had a score of 36, and a couple students had a score of 45, 46 using the old curriculum. Likewise, in the new curriculum students, right, there was one student who had a test score of 47, and then 50, and then 58, so on and so forth. Okay, so it's important to enter the data exactly as they are. Okay, if you make any mistakes, you will probably get an incorrect result. So let's go to the stat menu, tstats to sample with data, since we have the actual data values. Okay, so the sample 1 values are in the old column. Okay, I renamed the columns here. Then the sample 2 values are in the new column. All right, since we're assuming the variances are equal, check this box here. Select the appropriate symbol for the alternative hypothesis. Do an optional p-value plot. Click compute. This is the test statistic, round it to 3 decimal places. Okay, and check the answer.